Knowledge Nexus.
Hey everyone, welcome back to the channel. Today we're diving into a topic that's straight out of science fiction, but is quickly becoming a reality: quantum computing. Imagine a computer so powerful that it could solve problems in seconds, problems that would take classical computers billions of years. We're talking about harnessing the bizarre rules of quantum mechanics to revolutionize fields like medicine, materials science, and artificial intelligence. So, buckle up, get ready for a wild ride, and let's explore the fascinating world of quantum computing together. Alright, let's start with the basics. What exactly is quantum computing? Our everyday computers operate on bits, which can be either a 0 or a 1. But the universe is far weirder and more wonderful than a simple light switch. Enter the quantum world, where things exist in a haze of probability, the quantum equivalent of a bit. That's a qubit. A qubit can be a 0, a 1, or both at the same time. This is called superposition. Imagine a coin spinning in the air. Before it lands, it's both heads and tails simultaneously. This ability to exist in multiple states allows quantum computers to perform calculations in ways that classical computers can only dream of. It's like having a computer that can explore every possible path in a maze simultaneously. We're talking about potentially solving problems that are impossible for even the most powerful classical computers. Simulating complex molecules to design life-saving drugs, optimizing traffic flow, breaking encryption. These are just a few potential applications. Stick with me, and together, we'll demystify the quantum realm. Let's dive deeper into the differences between classical computers and quantum computers. Imagine a classical computer like a bicycle, a trusty machine that gets you from point A to point B using two wheels, representing 0 and 1. Now, picture a quantum computer as a spaceship. Classical computers use bits, which can be heads, 1, or tails, 0, but never both at the same time. Quantum computers use qubits, which can be in superposition, both heads and tails, simultaneously. This quantum quirk gives quantum computers their incredible power. Imagine searching through a maze. A classical computer would try each path one by one. A quantum computer could explore all paths simultaneously, making it exponentially faster at solving certain types of problems. This doesn't mean quantum computers will replace classical computers. Classical computers will continue to be great for everyday tasks. But for complex problems, quantum computers are poised to revolutionize our world. Mind's blown, because we're going deep into the quantum realm to explore superposition and entanglement. We've already touched upon superposition. Remember that spinning coin existing in both heads and tails states simultaneously. Qubits can be in multiple states at the same time. Now let's talk about entanglement. Imagine you have two spinning coins, linked in a way that knowing the state of one instantly tells you the state of the other. This mind-boggling connection allows quantum computers to perform operations on multiple qubits simultaneously. Superposition gives each qubit a superpower, allowing it to be in multiple states at once. Entanglement links these superpowered qubits, unlocking even greater computational might. These two phenomena are the cornerstones of quantum computing. They are the keys to unlocking the potential of this revolutionary technology. So we've talked about qubits, superposition, and entanglement. But how do these quantum ingredients come to create a functioning quantum computer? Picture this. A quantum computer is like a delicate orchestra, with qubits as its instruments. Instead of bows and reeds, we use lasers and microwaves to control and manipulate these qubits. And just like an orchestra needs a conductor, we need quantum algorithms to orchestrate the interactions between qubits and perform calculations. Creating and maintaining these quantum computers is no easy feat. We're talking about isolating these delicate qubits from any external interference. That's why quantum computers often operate at temperatures colder than the vacuum of space, near absolute zero. Despite challenges, the progress in quantum computing has been remarkable. Companies like Google, IBM, and innovative startups are racing to build bigger, better, and more stable quantum computers. Let's talk about the exciting part. What can we actually do with these quantum computers? The potential applications are vast and transformative. Let's start with cryptography. The security of our online data relies on complex mathematical problems that are difficult for classical computers to solve. But quantum computers could crack these codes like a cosmic safecracker. Researchers are already working on quantum-resistant encryption methods to keep our data safe. Imagine designing new drugs and materials at the atomic level, simulating the interactions of molecules with incredible precision. Quantum computing can revolutionize fields like finance and artificial intelligence. Imagine optimizing investment strategies with unparalleled accuracy, or developing AI algorithms that can learn and adapt at speeds we can only dream of today. Quantum computers could help us model complex climate systems with greater accuracy. These are just a few examples of the potential applications of quantum computing. As this technology continues to advance, we can expect to see even more innovative and transformative uses emerge. As we stand on the cusp of this quantum revolution, one can't help but feel a sense of awe and anticipation. The future of quantum computing is brimming with possibilities, a vast uncharted territory ripe for exploration and discovery. Remember, we are still in the early days of quantum computing, much like the early days of classical computing when computers filled entire rooms. But the pace of progress is accelerating, fueled by billions of dollars in investment and the tireless efforts of brilliant minds across the globe. Companies like Google, IBM, and innovative startups are making remarkable strides. We're witnessing a global race to unlock the full potential of this transformative technology. It's about understanding the fundamental principles of quantum mechanics and learning how to harness them to solve real-world problems. The quantum future is not predetermined. It's a future we are actively shaping with every experiment, every discovery, and every line of code. So stay curious, stay informed, and who knows, maybe you'll be the one to make the next groundbreaking discovery in the quantum realm. So there you have it, a glimpse into the fascinating and rapidly evolving world of quantum computing. We've journeyed from the basics of bits and qubits to the mind-bending concepts of superposition and entanglement. Remember, quantum computing is not just a niche field for scientists and engineers. It's a fundamental shift in how we understand and interact with information. From revolutionizing medicine and materials science to tackling climate change and advancing artificial intelligence, the possibilities are truly astounding. Embrace your curiosity, explore these resources, and never stop asking questions. Because the more we understand about the quantum world, the more we realize how much more there is to learn. So, what are you waiting for? The quantum revolution is upon us, and it's time for all of us to get on board. Dive into the fascinating world of quantum computing, explore the endless possibilities, and who knows, maybe you'll be the one to make the next groundbreaking discovery. If you enjoyed this journey into the quantum realm, give this video a big thumbs up. Subscribe to the channel for more mind-blowing content, and don't forget to hit that notification bell so you never miss an episode. And as always, keep those minds curious, keep exploring the universe, and I'll see you in the next video.